The most alarming possibility regarding 3I Atlas seems utterly wild at first glance, but ponder this. Suppose it's not just passing through. Imagine if that apparent flyby route is really a stealthy slowdown, pulled off by tech beyond our ability to spot. Picture a mind so superior that faking the laws of orbital physics is effortless. A society sending out spy probes masked as comets, rocks from space, or even junk floating in the void. The bizarre velocity and weird makeup of 3I Atlas could signal not some extraterrestrial origin, but deliberate design from afar. As it nears its closest solar point, concealed mechanisms might activate, gearing up for whatever goal sent it our way. This evening, we'll dive into those murky theories where everyday science falls apart and space-based suspicions grow wild. The real puzzle isn't if 3I Atlas will depart. It's if we'd even notice its choice to linger. Section 1. Does 3I Atlas spell danger? Back on July 1, 2025, the Atlas scope in Chile picked up something remarkable. A faint glimmer on a hyperbola-like path that screamed one clear truth. This guest hailed from a whole different star setup. Labeled 3I Atlas, once known as C2025 N0NE, it's our third verified wanderer from beyond, trailing Oumuamua from 2017 and 2I Borisov from 2019. Yet, what if this latest arrival hints at consequences way bigger than its predecessors? Consequences that redefine what doomsday even means. In contrast to locals stuck in oval loops around our sun, 3I Atlas carves a hyperbolic trail across the cosmos. With an eccentricity over 1 it's clearly free from Sol's pull. Hurtling in from the Lyra constellation at record paces, it'll hit perihelion on October 29th, topping 130 mph swift enough to zip across the U.S. in less than 3 minutes. Still, under all these solid calculations lurks a persistent doubt. What if the actual nightmare isn't its destination, but the insights it might expose about humanity? For all its blistering pace, 3I Atlas won't endanger our planet at all. Its nearest pass in mid-December stays around 1.8 astronomical units out, roughly 270 million kilometers, almost double the Earth-Mars minimum gap. NASA stands firm on this. It's just a regular comet. Nothing engineered or risky. But once we step past NASA's measured words into wilder territory, what doubts could this timeless drifter stir up about smarts, intent, and random chance in the stars? Hubble's been tracking it since the find, showing typical comet traits as sunlight vaporizes frosts in its core, forming a bright halo. The James Webb Space Telescope grabbed data on August 6th, spotting unusually rich CO2 levels, a makeup hinting at birth conditions alien to our system. That quirky composition, though, sparks a troubling thought. What if 3I Atlas's deepest meaning isn't its own makeup, but the unknowns it shoves in our faces? Telescopes on the ground everywhere have pitched in, with radio arrays detecting only organic signals and quiet where tech chatter could lurk. This united push shows today's stargazing at its peak, a worldwide web verifying the thing's out-of-system routes and safe route. But what unfolds when we stretch past safe and explore ideas that don't threaten our bodies, but shake our core views on where we fit in the cosmos? Such finds point to the cosmos littered with these roamers' scraps from world-building around far-off suns, hurled out by gravity's fury to drift for eons. Everyone reveals fresh galactic lore outside our star's domain, even as none endangers life here. Still, if the stars truly brim with these old envoys, what follows when we speculate past accepted science? As The Guardian put it well, 3I Atlas is a stellar oddity, not a disaster, a nudge that our reality is weirder and more linked than routine existence implies. This old traveler gives a short peek into the galaxy's ancient past, hauling clues from star zones we can hardly fathom. But suppose the core enigma isn't its hidden lore, but the doors it could open to the essence of star-crossing guests and the far-out what-ifs telescopes can't touch. Section 2. Velocity, scale, era, a subtle force. The figures by themselves boggle the mind. 3I Atlas clocks over 130 mph, about 150 times the zip of a potent gun round. Its hyperbolic leftover speed of 61 kilometers marks the pace it holds, even after gravity's tug. hunting for clues about solar pull, unaffected by countless ages of drifting through the galaxy. Yet, as we ponder the implications of such astonishing velocities in hypothetical situations well outside established science, what intriguing prospects arise that might completely reshape our view of potential dangers? This pace vastly outstrips those of prior interstellar travelers. Oumuamua clocked in at 26 kilometers, while 2I Borisov reached 32 km. 3 Atlas blazes along at almost double that rate, pointing to either a brutal launch from its home system or boosts gained via repeated gravitational slingshots on its stellar journey. Still, suppose this escalating speed pattern among 3 such intruders points to intent rather than mere chaotic cosmic forces. An idea that draws us into realms our tools can't probe. Pinpointing its dimensions is tricky thanks to the hazy envelope that veils the core. Estimates currently span 0, 3 to 5, 6 kilometers across, equivalent to a few soccer pitches up to a modest peak. The vagueness arises from guesses on surface brightness and how efficiently the coma forms. More compact sizes appear probable, drawing from standard comet traits, but even at 0, 3 kilometers it qualifies as a hefty chunk. However, imagine if the very ambiguity clouding our readings hides prospects that stretch well past basic scale inquiries. Such dimensional doubts spark compelling inquiries into resilience. How might a fairly unassuming form withstand the ferocity of expulsion, then survive eons or epochs in the void between stars? Tiny bodies risk more from gravitational shredding and collisions with space junk at blistering velocities. But suppose the key to its endurance unlocks imaginative ideas on toughness, intent, and construction that go past ordinary origins. Most captivatingly, 3I Atlas probably boasts immense age. Studies indicate roots in the galaxy's thick disk, a veteran star cluster from the Milky Way's turbulent youth. Should that hold true, this wanderer might outdate our solar setup by billions of years, harboring in its heart tales of galactic growth from an era when the cosmos was under half its present span. Yet, what if this vintage backstory lays the groundwork for imaginative tales that upend our grasp of chronology, function, and interstellar smarts? The thick disk theory stems from its path against the galaxy's whirl. Whereas nearby items orbit in sync with the galactic flow, 3I Atlas barrels in from an odd direction, implying ties to an ancient, haphazardly aligned group. Veteran stars whose paths remain unkempt after eons of galactic shaping. Still, if we step past stellar readings into imaginative zones, what could this quirky incoming vector imply about guidance, steering, and aims surpassing simple celestial paths? For all its blistering velocity and enigmatic past, 3I Atlas carries no orbital peril. Its hyperbolic path, the hallmark of interstellar origin, ensures a harmless flyby. It zips by too swiftly for the sun to snag, with nearest planetary brushes spanning astronomical units, not mere kilometers. But as we gear up to delve into uncertainties past proven facts, what if true dire outcomes stem not from crashes, but from the symbolism this guest embodies? Viewing opportunities bring hurdles. Top luminosity near magnitude 11 demands scopes, even in ideal skies. At perihelion, it vanishes into the sun's blaze precisely as it ramps up activity, a stellar schedule that borders on suspiciously timed. Yet, imagine if this seeing constraint serves as the entry to imaginative setups where unseen aspects outweigh observable data? What surfaces as an image of stellar toughness, aged, swift, and transient? 3I Atlas captures the blend of striking dynamics and negligible hazard, underscoring how the cosmos unfolds on vast canvases beyond human scale, yet adheres to rules sharp enough to forecast this intruder's spot years ahead. But if we probe what hides past these charted paths, what imaginative dire visions, surface ones, tied not to paths, but to disclosures from the stars? Part 3. Elements in the Void. Turbocharged Cotton. As JWST's heat-sensing eyes scanned 3I Atlas on August 6th, it uncovered a marvel. An envelope rich in carbon dioxide, boasting a CO2 to H2O proportion of roughly 8:1. This went beyond rare it defied known comet compositions. But as we edge from molecular breakdowns into imaginative domains, suppose this chemical mark alludes to roles and births that reach past standard creation paths. Everyday comets stick to expected patterns. Water ice prevails in such environments, turning directly into gas at relatively low temperatures and forming the typical vapor tails blended with particles. Next comes carbon monoxide, then carbon dioxide along with minor substances. The proportions of these molecules reveal insights into the conditions under which they originated and their subsequent development. However, 3i Atlas has completely upended this conventional narrative, generating CO ices on a massive scale reminiscent of large-scale atmospheric manufacturing. Could this departure from standard behavior unlock imaginative hypotheses that question our fundamental distinctions between natural and engineered beginnings? The measurements gain even greater significance when factoring in the viewing range. At the time Webb obtained its spectral data, 3i Atlas was more than 3 astronomical units away from the Sun, far past Mars. Comets typically exhibit minimal signs of activity at those ranges. Nevertheless, this body generated a noticeable CO-dominated envelope that stretched for hundreds of thousands of kilometers around its core. Imagine if this puzzling vigor at such extreme separations lays the groundwork for theoretical ideas concerning power origins, inner operations, and objectives that surpass our present grasp of natural limits. Various hypotheses seek to account for it. 3i Atlas may have originated close to the CO2 frost line of its birth star, where carbon dioxide favored accumulation from the surrounding protoplanetary material. On the other hand, its advanced age combined with cosmic radiation exposure might have altered the outer layer's makeup, forming irradiated shells that trap water yet permit CO vapors to seep out. Another possibility entails dust coverings that built up across eons, functioning as stellar barriers to block water while letting more volatile CO2 filter through. Still, suppose these seemingly reasonable natural accounts overlook the most disturbing option, that this molecular profile indicates intentional design for aims beyond our current perception. Webb's near-infrared instrument identifies molecular traces with remarkable accuracy. As solar warmth energizes the envelope, substances release radiation at distinct wavelengths, disclosing their makeup. The detected OC ratio stands as one of the highest CO2 enrichments documented in comet studies. Yet, venturing further into conjecture, what if these molecular patterns carry data extending past basic reactions, perhaps signals or clues to intentions that upend our views on extraterrestrial awareness? This concept isn't wholly novel. Comet C2016 R2 pan-stars likewise showed irregular volatile proportions featuring odd levels of carbon monoxide and nitrogen. These compositional oddities imply either greater variety in comet origins than models predicted or intense alterations after formation that reshaped outer layers. However, edging into outright theorizing, suppose these irregularities across several bodies suggest a trend, a mark directing us toward prospects outside the safe confines of straightforward natural causes. The worth of 3i Atlas rests in embodying chemistry from wholly alien stellar settings. Whereas pan-stars arose in modelable circumstances, this interloper bears traces from dynamics near other stars, conceivably from billions of years back. Extraterrestrial rock formations brought right to us. But what if this arrival feels less like chance than we think? And which imaginative narratives arise if we ponder that long ago minds could embed data within the very elements we're analyzing? Continued monitoring will clarify if the CO2 prevalence reflects the overall structure or just the exterior. With rising solar exposure, the mix of molecules might evolve if underlying water ice exists beneath CO-rich outer zones, possibly exposing inner strata via varying heat depths. Yet, imagine if these evolving profiles as 3i Atlas nears its closest solar approach display not haphazard warming, but deliberate triggering, paving ways for ideas about inactive setups stirring under stellar pull. This tale of chemical sleuthing reaches past the details of 3i Atlas alone. Should interstellar visitors often reveal strange makeups, then world-building around distant suns yields a broader array of frozen objects than in our own setup. The CO abundant setting that molded 3I Atlas could mirror routine scenarios near specific star classes or growth phases. But poised at speculation's edge, what if these peculiar blends signify intent far deeper? Beacons, maybe, or traces guiding to a universe teeming with minds we're just starting to sense via their molecular imprints. From wider angles, this odd chemistry probes models of world creation stretching past our solar realm. If concepts on frozen body genesis and progression hold true, they ought to encompass observed variations among cosmic wanderers from beyond our solar system. 3I Atlas defies predictions, pointing to possible shortcomings in our theories, or merely the wide array of conditions in uncharted galactic regions. Still, as we step outside established models into unbridled conjecture, could the puzzle this interloper poses to our frameworks signal something deeper? Indications of mechanisms, intentions, and minds functioning outside the physical principles humanity has charted for ages. Section 4. Direst outcome resolved. Almost 2,000 terms into this probe, the alleged grimmest possibility turns out intriguingly ordinary. No blockbuster disaster looms. No society-shattering collision endangers our world. No tidal forces hurl Earth toward ruin. Cool, exact orbital dynamics yield a judgment that ought to let us rest easy. However, as we gear up to explore past the security of empirical facts, suppose the true gravest possibilities dwell not in the domain of physics, but in the conjectural gloom where our tools fall short and our doctrines hesitate to probe. Those key figures merit restating. 3I. Atlas draws no nearer than 1. 8 astronomical units to Earth, a 270 million kilometer cushion of reassurance. This surpasses double the minimal Earth-Mars separation and amounts to more than 50 times the lunar distance. Its closest solar approach happens near October 29th at about 1. 4 astronomical units from the Sun, situating it midway between Earth and Mars paths. Near enough for notable stellar warming and impressive CO's dust-tail formation, yet far from influencing orbital paths or scattering fragments onto any planet. But suppose separation loses meaning when pondering hypothetical cases with advanced tech, intellects, or aims that bypass limits of mere closeness. These figures stem from meticulous path computations that factor in primary planetary pulls, relativistic factors, and minor tweaks from light pressure. When stargazers assert 3I Atlas offers no peril, they rely on authority forged from ages of sky motion studies and years monitoring risky bodies. Yet, imagine if the math safeguarding our bodily security lays the groundwork for imagined dire outcomes unrelated to impacts, centered instead on interaction, exchange, and universal insights. The initially startling pace exceeding 130 kilometers ultimately benefits us. Bodies on escape path orbits at those rates evade the sun's gravitational hold. 3I Atlas zips by too swiftly to hang around and stir issues, executing its stellar skim before vanishing into deep space once more. But what if this velocity, this resistance to entrapment, suggests more than routine path dynamics? What if it points to intentional engineering, exact scheduling, and objectives stretching past our present means of sensing or grasping? This underscores vital differences in conveying risks that cosmic organizations handle with care. Interstellar evokes strong feelings disconnected from real hazards. Instinctual reactions to nearing mysterious entities clash with spatial truths. The immense expanses of space and path rules align to render such meetings captivating instead of perilous. Yet, what if dwelling on bodily threats distracts from alternative dangers? The imagined cases where the harshest outcome concerns not actions by 3I Atlas against us, but disclosures it might force about ourselves, our beliefs, and our role in a cosmos far more peculiar than we venture to conceive. NASA's messaging achieves an ideal equilibrium, recognizing research value while stressing the lack of peril. Straightforward, non-technical wording clarifies why this body stands out as extraordinary yet safe, sustaining curiosity and true breakthroughs without sparking unwarranted worry. Earlier cosmic intruders offer further backdrop. Oumuamua raised no alarms in 2017 despite odd traits, whereas 2I Borisov showed expected outgassing in its 2019 transit. 3I Atlas upholds this trend of intriguing yet kinematically benign intruders. But poised on speculation's edge, what if this sequence of innocuous passers-by conceals something vastly greater? A stellar census maybe, or a slow unveiling that upends all our notions of cognition, intent, and our stellar surroundings. Our present knowledge builds a reassuring base. We grasp its velocity, course, and distinctive CO2-heavy makeup. Data implies considerable antiquity and roots in the galaxy's thick disk. Several premier observatories yield in-depth views of its molecular profile and motion traits. These certainties sketch images of aged, swift, element-odd, yet essentially ordinary icy bodies. Yet, hidden under this reassurance, amid the bedrock of certainties, dwells the vast enigma. What imaginative possibilities arise when we venture to inquire not merely about the nature of 3I Atlas, but its potential symbolism in a universe where sentience might manifest in ways beyond our wildest conceptions? Key mysteries persist. Accurate measurements of its nucleus span from mere hundreds of meters to a few kilometers. Debates over surface versus internal makeup accounting for its COI prevalence stay unresolved. We lack the means to identify its birth star system or recreate the exact orbital interactions that molded its path today. Importantly, these gaps hold no bearing on hazard evaluations. Yet, imagine if they sparked visionary narratives that stretch well past the secure confines of conventional interpretations. Such an approach highlights sound celestial hazard analysis, separating curiosity from genuine perils. News outlets have mostly echoed this balanced stance, spotlighting both its scholarly worth and benign essence. Photographic proof delivers uniform narratives. Hubble snapshots display standard comet traits. Webb readings uncover atypical yet organic makeup. Earthly telescopes monitor steadily shifting outflows. Datasets show no engineered pulses, heat patterns, or directed motions. Still, suppose this lack of evident artifice opens the portal to musings on intellect so sophisticated and elusive that it evades our present tools for spotting or grasping it. All readings converge on the same verdict. 3I Atlas embodies precisely what it seems, an organic comet bearing traces of foreign stellar chemistry, adhering strictly to cosmic physical principles. This validation of universality marks one of astronomy's deepest insights, and the direst projected physical dangers to our planet have been fully refuted. Equations hold firm, sightings align, findings comfort. This interstellar guest arrives without malice, by design or chance. Here arrives the juncture where we purposefully cross from the shelter of confirmed knowledge into unbridled conjecture, where grim hypotheticals assume wholly novel shapes, not assaults on our existence, but provocations to our grasp of potential realities in a cosmos potentially teeming with life, minds, and intentions far exceeding our paradigms. Section 5. Extraterrestrial artifacts or mere comet. We now intentionally breach the line from verified reality into conjecture's domain, where options proliferate like echoes in an infinite chamber. All that ensues must be viewed as intellectual exercise, not proven theory, a cognitive excursion into the conceivable, sharply set apart from established truths. The data, as outlined, overwhelmingly supports 3I Atlas as a routine comet, but consider the implications if that data proved partial or deceptive somehow. The core stance endures unaltered. NASA, ESA, and nearly all leading astronomical bodies classify 3I Atlas as a standard interstellar wanderer. This reflects no mere institutional inertia or cautious dogma. It simply matches the evidence most effectively. The body exhibits typical comet dynamics, obeys expected trajectory rules, and exhibits light profiles matching vaporizing frosts. Occam's razor, that core tenet of logical inquiry, decisively backs the organic account. Yet, history shows science thrives on shocks, with breakthroughs often stemming from seemingly ordinary finds. Pulsars debuted as enigmatic radio bursts, so rhythmic they earned a short-lived tag as LGM Little Green Men, until unveiled as spinning neutron stars. Swift radio bursts perplexed experts for ages before exposing ties to bizarre universal events. Might 3i Atlas signal yet another instance of nature outstripping our first impressions? Ideas of engineered beginnings don't sprout from nothing. Avi Loeb, the Harvard astrophysicist noted for his bold takes on Oumuamua, has started proposing akin notions for 3i Atlas across talks and online writings. Loeb's view, presented as personal viewpoint rather than settled truth, urges us to stay receptive to interstellar travelers possibly being artifacts over mere debris. This angle warrants thoughtful review, not for its guaranteed accuracy, but for demonstrating rigorous scrutiny of bold assertions. What proof would seal an artificial source? Which sightings would compel us to discard the comet theory for bolder alternatives? Such queries prove vital as they sharpen our ability to differentiate. A balanced approach involves fostering healthy scientific doubt alongside a cautious rejection of fringe concepts. Should the Atlas object truly represent some engineered creation, we'd anticipate detectable markers setting it apart from ordinary celestial bodies. For example, organized radio signals could hint at embedded technology or signaling devices. These would have to demonstrate unmistakable human-like origins, distinct from the haphazard electromagnetic static that every body in space generates, instead featuring patterned broadcasts impossible under natural conditions. Unexpected non-gravitational shifts in speed, unrelated to gas venting, would serve as another key indicator. Typical comets display minor path alterations from gravitational paths due to the minor push from vaporizing ices. Yet, if Atlas deviated in velocity without ties to gas release, or if its motion didn't align with solar proximity cycles, that could point to an intentional drive mechanism. Deliberately designed luminosity patterns, the fluctuations in an object's visible intensity, might offer further clues. Standard comets generally increase in brightness steadily as they near the Sun, with changes tied to spin rates, uneven surfaces, and gas ejection behaviors. A manufactured entity could exhibit light shifts governed by alternative principles, such as deliberate attitude adjustments or functioning onboard apparatus. To date, no such engineered traits have appeared in Atlas. Observations from radio arrays have captured only cosmic quietude and the routine outflows typical of melting comet ices. Its path adheres strictly to orbital dynamics, free of puzzling irregularities. The object's light fluctuations match those seen in fellow comets as they spin and react to sunlight. The prevalence of carbon dioxide that renders Atlas compositionally distinctive doesn't inherently imply a synthetic source. As noted before, various innate mechanisms might yield CO2-heavy profiles. Processes like irradiation of outer layers near CO snow boundaries in young solar systems or the buildup of protective dust layers could all explain the noted makeup. Leaping to a built-from-scratch conclusion demands proof that rules out every natural alternative. Here, insights from Oumuamua prove especially instructive. That inaugural, verified extrasolar guest ignited fervent debates on its potential crafted essence, fueled in part by its odd cigar-like form and subtle speed-up. Telescopes scoured for tech signals but detected zilch. In-depth study of its path showed that vapor from H2O ice sufficed to justify the anomalous pulls. What first appeared as bafflingly alien eventually yielded to everyday rationales. This precedent outlines a smart strategy for assessing Atlas. Stay receptive to wild ideas, but insist on ironclad proof. Science thrives exactly by subjecting every idea, mainstream or outlandish, to identical evidentiary scrutiny. Assertions of a synthetic backstory must satisfy those criteria beyond just highlighting holes in existing knowledge. Ethical reporting on these hypothetical angles demands explicit caveats and fitting framing. When news sources explore the chance of a built atlas, they ought to flag it boldly as conjecture, not verified fact. This separation matters beyond theory. It shapes public views on the object itself and science's investigative core. Such pondering has real value past idle fun. Pondering crafted origins sharpens our grasp of what separates organic space stuff from the made kind. It spurs creation of checks that might debunk the comet theory and underscores that the cosmos could yet surprise us with paradigm shakers. Ongoing watches will probe these iffy notions further. New spectral data as Atlas nears its closest solar pass might uncover elemental traces hard to pin on routine origins. Accurate position tracking could spot path quirks implying guided travel. Extended surveillance may uncover habits clashing with inert comet norms. Still, the onus lies with advocates of built theories. The everyday comet model benefits from alignment with proven laws, familiar comet traits, and traits of past interstellar wanderers. Displacing that agreement would demand compelling proof. This compelling example underscores the limitations of purely natural interpretations and lends credence to more engineered possibilities. The conceptual exploration of such ideas should not overshadow the astonishing essence of what 3i Atlas truly embodies. Even if it turns out to be a typical comet, this ancient traveler holds clues about distant star systems we've yet to explore, ancient chemical reactions from eons past, and the intricate past of our local cosmic region. That's impressive on its own, without needing far-fetched theories. As we press on with this imaginative inquiry, it's essential to recall that astronomy's greatest breakthroughs frequently stem from meticulous study of seemingly mundane features. Pulsars, quasars, gamma-ray bursts, and gravitational waves all started as enigmatic signals that later unveiled groundbreaking principles. Regardless of whether 3i Atlas ends up as a standard comet or an outlier, it has already broadened our grasp of the space between stars and the variety of wanderers drifting among them. Our next foray into conjecture will dive into bolder hypotheticals, not due to their probability, but because they highlight the intriguing dilemmas that surface when we face something utterly novel in our universe. These intellectual forays will test the edges of feasibility while firmly separating conjecture from verified knowledge and fantasy from reality. Part 6. The bleakest hypothetical outlook, a dark forest catalyst. We now plunge into the most profound speculative domain, where the enigmas of cosmic potential lead to ideas that could reshape our view of humanity's role in the cosmos. What comes next is entirely hypothetical, an intellectual voyage into ramifications and prospects, unsupported by present data, yet capable of sparking deep inquiries if our views on 3i Atlas fall short. The dark forest theory draws from science fiction and rigorous SETI discussions alike. Named after Liu Cixin's celebrated book, it embodies a legitimate philosophical stance on interstellar societies. The concept posits that sophisticated civilizations may choose to stay concealed from each other, presuming that exposing their presence and strengths might provoke attacks from superior rivals. In this kind of cosmos, quietude serves as a defense mechanism, and any group that signals its location invites destruction from dangers it can't detect or grasp. If we indulge in this purely fictional notion and emphasize that it's just that envisioning 3i Atlas is more than a natural comet, perhaps a scouting device, the consequences would be profound. This setup would imply that our solar system is under scrutiny by minds advanced enough to craft items enduring multi-billion-year voyages across the void, all while blending seamlessly with ordinary space debris. The flawlessness of its camouflage would signal a technological prowess that eclipses our own by orders of magnitude. Ponder the technical demands of such a setup. To pose as a comet, the device would have to replicate every facet of genuine cometary action. Accurate spectral profiles, fitting vapor release behaviors that react authentically to sunlight, and surface traits that scatter light like typical frosts and stones. It would require ample icy substances to sustain the illusion across its solar system transit, all while concealing any instruments, operations, and signaling gear essential for the venture. The energy needs would be immense on their own. Sustaining functional components over vast interstellar spans and immense timescales would call for power systems we can't yet conceive. A radioisotope thermoelectric generator might supply energy for thousands of years, or perhaps compact fusion units could draw from sparse cosmic hydrogen. The craft could draw from cosmic radiation or electromagnetic encounters en route. Yet let's escalate this imaginary tale to its climactic peak. Suppose our ongoing scrutiny of 3i Atlas uncovers irregularities defying ordinary mechanics, Radio observatories might pick up fleeting patterned signals as it traverses the system's fringes. Its path could exhibit tiny, undeniable adjustments hinting at deliberate control. Or its gaseous outflows might show arrangements too intricate and deliberate for mere haphazard evaporation. The pivotal instant in this imagined storyline could emerge when 3i till. As the probe starts releasing its auxiliary devices, smaller units detach from the primary structure and position themselves across our solar system. One could circle Venus, another might orbit Mars, with additional ones dispersed amid the asteroid belt or stationed at stable Lagrange points. In an instant, our solar system would be dotted with a mysterious monitoring array of indeterminate origin and prowess. The immediate dilemma would be, what's humanity's best course of action? This imagined situation would thrust us into the most profound diplomatic and tactical predicament our kind has ever encountered. Rather than the slow-building encounters popularized in sci-fi tales, stumbling upon a functioning oversight grid would force us to grapple with evidence of advanced extraterrestrial intellect already active right in our cosmic backyard. Uncharted and pressing governance issues would emerge. Who gets to represent Earth? Options might include the United Nations, leading space organizations, nations boasting cutting-edge orbital tech, or the researchers who first spotted it. The sheer difficulty of forging worldwide agreement on an event of this magnitude boggles the mind, especially considering our history of fumbling even basic collaborative efforts. The ongoing SETI conversation, whether to broadcast our existence or just eavesdrop for incoming signals, would pivot from abstract debate to urgent reality. Critics warn that broadcasting could draw dangerous scrutiny from aggressive extraterrestrials. Proponents insist that passive skywatching with ever-refined tools offers scant safeguard anyway. An interstellar-capable society would probably pick up on our tech footprints no matter our signaling choices. Yet, in this thought experiment, that decision could slip out of our hands. Should 3i Atlas and its imagined offshoots be scrutinizing human society, our reactions would feed directly into their gathered intel. Staying quiet could signal prudence or timidity. Outreach efforts might imply belligerence or inquisitiveness. Even our squabbles over strategy would expose core traits of human psychology and societal frameworks to any observers. Managing the crisis messaging would prove daunting. How do you alert the world to extraterrestrial monitoring without sparking mass hysteria? How do you uphold empirical rigor amid concepts that stretch beyond our grasp? How do you separate confirmed data from wild guesses when the outcome might shape humanity's destiny? Events would probably play out via panels of specialists, urgent meetings of research bodies, and measured announcements to the public. Leaders would have to weigh openness against order, sharing sufficient details to build trust without igniting the chaos tied to verifying our initial brush with alien presence. Fake news would loom large as a threat. Just hinting at otherworldly watchers could unleash a torrent of wild theories, staged event claims, and cover-up rants. Separating solid evidence from nonsense would be vital to sustaining level-headed dialogue on the pivotal breakthrough of our era. The tech ramifications would run just as deep. If 3i Atlas showcased feats defying our physics, it could unlock breakthroughs in drives, power sources, materials, or signaling that propel human innovation forward by ages, provided the probe's creators let us persist and evolve. Yet the most disquieting facet of this conjecture might involve the timelines. If 3i Atlas has journeyed for eons, it could hail from an era when our galaxy looked utterly transformed. The beings who sent it may have vanished long ago, bequeathing self-running machines to fulfill tasks plotted by forebears who perished before our sun ignited. This evokes an eerie prospect. Not lively alien meddling, but echoes of a bygone era, self-sustaining apparatuses adhering to coded instructions over vast epochs, may be untethered from any extant minds, yet doggedly pursuing preset goals with unerring automation. Naturally, and worth stressing repeatedly, none of if this hypothetical scenario aligns with ongoing data from the 3 Atlas observations. Each reading, spectral analysis, and photograph reinforces the idea of it being a typical comet. The entity acts precisely in line with what celestial mechanics expects from a visitor from outside our solar system. Its molecular makeup, though distinctive, aligns with outcomes from ordinary cosmic events. Its path adheres strictly to gravitational principles, needing no outlandish theories to explain it. The merit of such a thought experiment isn't in its likelihood, but in demonstrating how rapidly our view of the cosmos might shift if our preconceptions fall short. It serves as a reminder that the cosmos has caught us off guard in the past and will undoubtedly do so once more. Moreover, it underscores the need to balance reasonable doubt toward bold assertions with receptivity to ideas that stretch beyond what we know today. Yet, as we venture further into this realm of conjecture, keep in mind that we're charting the realm of what could be, not mapping out proven truths. The genuine 3 Atlas stands as an intriguing cosmic oddity, old, swift, with atypical chemistry, yet entirely explicable through our existing scientific models. Whether those models hold up in the end is still unresolved, though upcoming data will settle it with the unyielding precision that evidence alone delivers. Part 8. Great Filter Warnings. The notion of the Great Filter arises from one of the deepest riddles confronting advanced societies. Given that the cosmos ought to brim with smart beings, why is there zero sign of them? This enduring conundrum, first voiced by physicist Enrico Fermi in the 1950s, has fueled endless debates on obstacles that could block life from emerging, advancing, or enduring long enough to colonize the stars. In our imaginative probe of 3i Atlas, we have to grapple with the chance that this timeless drifter bears signals from minds that hit their own unbreakable walls. The Great Filter idea posits that along the vast progression from basic molecules to galaxy-spanning societies, there's a phase so unlikely, arduous, or risky that nearly every effort to overcome it ends in collapse. That barrier might strike early on, say during the shift from inert substances to replicating entities. Or it could surface later as societies invent tools potent enough to wipe themselves out before mastering their safe application. Should we entertain the thought that 3 Atlas is crafted tech instead of a natural body, we instantly face inquiries about what became of its builders. The item's seeming antiquity, possibly spanning billions of years, roots its beginnings in the galaxy's distant past, amid stellar clusters, element distributions, and universal states far removed from today's. If this vintage intruder was truly constructed, did its originators last long enough to witness its arrival in our neck of the woods? The durations at play defy easy grasp. Human society, from initial farming villages to our present era of space travel, covers about 10,000 years. Written records span roughly 5,000 years. Our tech-driven era has lasted just a few hundred years, but 3 Atlas, assuming human-made, would embody machinery active for countless multiples of our whole societal timeline. This prompts deep reflections on how long tech can endure compared to living populations. The most chilling scenario might be that we're coming across scouts that outlive their creators by eons. Stellar dispatches adrift in the void, bearing data from groups that cracked the code of star-to-star messaging, yet fell to different facets of the Great Filter. Ponder the design feats needed for gear that stays viable over such epochs. Humanity's toughest relics, like the pyramids, enduring rock structures, select decaying elements, function across thousands to millions of years. Yet, sustaining intricate circuits, drive systems, and synthetic minds over billions of years would call for design concepts beyond our wildest dreams. It would necessitate materials tougher than any gem, power sources outlasting stellar lifespans, and code frameworks able to evolve and fix themselves over eras rivaling planetary ages. Such an achievement would, ironically, imply that its architects wielded phenomenal prowess. Any group able to dispatch year-long voyages between stars would have conquered. It faces a multitude of engineering hurdles that we've scarcely started to tackle. These beings would manipulate substances down to the molecular scale, harness power production and retention on vast astronomical levels, and handle data computation spanning eons. Abilities like these could shield against various threats that might represent Great Filter events. However, Supposing 3 Atlas truly originated from them, and assuming it's the sole trace we detect of their presence, what formidable barrier could have overtaken them in spite of their advanced expertise? The options are profoundly disheartening to ponder. They could have suffered from exhaustive depletion of resources across the galaxy, growing so aggressively that they exhausted the vital energy and resources essential for their society's endurance. It's possible they clashed with rival intelligent entities that turned out aggressive, igniting wars that annihilated both sides. Even more disturbing, they may have been undone by inherent tensions within a highly sophisticated tech-based society. The very tools that let them craft probes for the stars might have facilitated devastating conflicts, ecological ruin, or societal breakdown that spiraled beyond containment. The annals of history brim with instances of societies that innovate tools faster than they cultivate the prudence to wield them without peril. Humanity today grapples with multiple dilemmas of this sort. On another note, the Great Filter could sidestep outright apocalypse, opting instead for a kind of evolutionary leap. Highly evolved societies might inevitably evolve in manners that make them invisible or incomprehensible to up-and-coming races such as ours. They could transfer their awareness to quantum networks, integrate with machines so seamlessly that the line between sentience and creation blurs entirely, or elevate to elevated planes of reality that elude our present senses. Grasping these ideas from a universal viewpoint can provoke a dizzying sense of awe. Our Milky Way hosts about 400 billion stars, a good number of which sparked into life billions of years prior to our sun's birth. Should just a small percentage of those solar setups yield tech-savvy societies, the galaxy ought to have been scouted and settled repeatedly. The lack of clear extraterrestrial signs termed the Great Silence by stargazers calls for answers. Today's SETI efforts mirror the doubt sparked by these inquiries. The bulk of hunts rely on quiet observation over bold signaling, based on the idea that broadcasting our location before grasping the interstellar landscape could be hasty or risky. Finding engineered traces in 3 Atlas would swiftly elevate these cautious hunts to pressing tactical priorities. The safeguards in observation that we've set during this probe grow all the more vital amid Great Filter deliberations. Existing findings on 3i Atlas still back organic origins for its actions, makeup, and path. Conjectures regarding engineered beginnings and societal downfall stay just that, conjectures lacking proof, sustained merely for thoughtful rumination. Still, the inquiries sparked by such musings transcend pure theory. They compel us to grapple with core dilemmas surrounding tech evolution, societal endurance, and our kind's future outlook. If mature civilizations habitually hit roadblocks that block their persistence over cosmic eras, what insights could that offer for humankind's path ahead? The Great Filter idea acts as both cautionary tale and motivator. It cautions that tech mastery by itself doesn't ensure longevity, that progress introduces fresh hazards alongside chances. Yet it also spurs us to deliberate wisely on steering our growth, harmonizing discovery with foresight, and devising fixes that outlast the societies birthing them. Within this hypothetical tale, 3 Atlas emerges as a relic from cosmic antiquity, tangible proof of intellects that mastered stunning feats of engineering, yet ultimately yielded to unknown perils. The device presses on with its timeless voyage through the ages, bearing signals from intellects that cracked the puzzles of star-spanning tech, but couldn't conquer the greater puzzle of enduring existence. This outlook would cast humanity as stewards of the cosmos, unearthing tech from forerunners who ventured routes we're just starting to tread. The duty would be immense, drawing wisdom from their triumphs while evading the Great Filter that felled their realm. The consequences would touch on no less than our species' final fate and our chance to add value to the universe's dialogue. But these stay as contemplative musings. Instead of drawing firm scientific verdicts, the genuine 3i Atlas persists in acting just like typical comets would, adhering to paths shaped by gravitational forces and physical laws instead of deliberate guidance or purpose. Whether this perspective will ultimately suffice is still up for debate, though ongoing monitoring and data will settle the matter in the end. As we push further into realms of conjecture, it's crucial to highlight the gap between our speculations and established knowledge. The cosmos has already revealed itself as profoundly odd via ordinary mechanisms, ranging from quantum intricacies to the enigma of dark energy and the vast network of galaxy-spanning structures. Injecting sentient intelligence into this remarkable tapestry could turn out to be redundant for sparking the awe and broad viewpoint that fuels every pursuit in science. Section 9. The quiet murmur of "Where is everybody?" This query reverberates across each breakthrough in astronomy, shadows every hunt for alien minds, and lingers in those instances when we gaze into the void of space only to encounter emptiness. Enrico Fermi first voiced it amid a relaxed midday chat back in 1950. Yet its weight has deepened considerably as our grasp of the universe has widened. Given that the Milky Way ought to brim with sophisticated societies, and the broader cosmos provides endless chances for life to emerge and develop, then why the apparent solitude? The Fermi paradox gains fresh layers when we examine wanderers from outside our solar system, such as 3I Atlas. Every such interloper from interstellar realms serves as an unplanned test of how material spreads across the galaxy, offering glimpses into the substances and dynamics unfolding near distant stars. Theoretically, these roving envoys could one day expose traces of engineered societies, synthetic compounds, altered isotopic balances, or crafted artifacts hinting at purposeful creation. However, every verified interstellar arrival to date has shown itself entirely organic. This lack of anomalies could signal something significant regarding the essence of evolved cultures and their ties to the spaces between stars. Maybe highly progressed entities opt for what we'd term stealthy messengers. Should they dispatch scouts, those devices are built to blend seamlessly with everyday cosmic events. Under this view, the very refinement of extraterrestrial tech would make it undetectable by our present tools, which are tuned to spot blatant signs of human-like intervention. Still, this prompts urgent inquiries into the form those indicators might take. If 3I Atlas truly functioned as a hidden scout, what data from surveys would expose its hidden essence? Such a puzzle circles back to the core divide separating organic and constructed features in the heavens, a line that could turn out far more nuanced and intricate than we presently realize. Focused radio bursts would stand out as the clearest mark of tech activity. Cosmic natural events generate radio static over wide bands, whereas deliberate broadcasts usually channel power into slim spectral peaks that pop against the universal hum. Efforts to find otherworldly smarts have zeroed in on capturing these precise kinds of transmissions for generations, based on the idea that any group able to chat across stars would leave traceable energy footprints. To date, 3I Atlas has stayed utterly quiet on the radio front, releasing just the expected glow from icy comet stuff vaporizing amid solar particles and field interactions. Specialized SETI scans have detected nothing structured, no pattern beams, no tweaked signals, no crafted rhythms in its energy emissions. This quietude fits the ordinary comet model to a T, yet it doesn't completely dismiss stealthier tech tricks. Odd heat patterns could serve as a different probe. Everyday items in the void reach a balanced warmth with their surroundings via proven rules of physics. They take in sunlight, release warmth in the infrared range, and hold steady surface heats based on their solar proximity, makeup, and heat-handling traits. Man-made items might show warmth spreads that defy these norms, hidden internal warmth, uneven warming, or control setups implying deliberate oversight. Up-to-date infrared scans of 3I Atlas reveal heat signs matching sun-warmed ordinary comet stuff. Its outer warmth climbs nearer to the sun, obeying the inverse square rule for sunlight spread. The way heat scatters over its exterior seems haphazard, influenced by landforms and material mixes, instead of planned warmth controls. Sea-controlled trajectory adjustments would offer the strongest indication of an artificial source. In space, natural bodies adhere to paths shaped purely by gravity, along with sporadic boosts from material venting. These extra gravitational influences are usually minor, unpredictable in orientation, and strongly linked to indicators of comet-like behavior, such as the glow of surrounding dust and gas emission levels. In comparison, engineered spacecraft could exhibit deliberate path alterations, purposeful speed adjustments, or route changes aligned with mission goals. Distinguishing such actions from the erratic effects of uneven venting would require caution, yet consistent signs of directed movement would emerge via accurate positional tracking. 3I Atlas displays no evidence of such directed adjustments. Its path traces the expected smooth hyperbolic curve based on gravitational models, with slight deviations that match precisely the anticipated impacts of sunlight pressure and venting dynamics. Should it have propulsion systems, they are either dormant or operating at levels beyond our present detection capabilities. The organic account for interstellar travelers like 3I Atlas fits seamlessly with models of how planetary systems develop. Simulations indicate that every star system ejects large amounts of rocky and frozen fragments during its formative stages. As planetary gravity disrupts minor bodies, hurling them toward interstellar space, our galaxy ought to teem with these drifters' failed planets that started coalescing near other suns but were cast adrift before maturing. Viewed this way, the gradual influx of interstellar arrivals we're now spotting matches precisely the forecasts from celestial mechanics. 1I Oumuamua, 2I Borisov, and 3I Atlas herald a far vaster group that upcoming observations will uncover. The Vera Rubin Observatory, set to launch operations in the coming years, is poised to spot several such objects annually, shifting them from oddities to everyday sights in astronomy. This numerical reasoning offers a potential answer to how the Fermi paradox applies to interstellar visitors. If ejected rocky remnants vastly exceed any manufactured explorers, the technological markers we're hunting could blend into a sea of organic roamers. Spotting extraterrestrial artifacts would mean picking out a handful of crafted items amid thousands or millions of innate ones, a challenge akin to finding a needle in a haystack, fraught with immense hurdles. The varied makeup uncovered in 3I Atlas layers onto this quantitative view. Its abundance of carbon dioxide broadens our understanding of volatile proportions in these wanderers, implying that diverse stellar settings yield varied cast-off substances. With expanding collections of examples, we might find that chemical traits we first saw as odd or possibly engineered simply reflect the galaxy-spanning variety in how planets coalesce. Biases in our detection methods muddle our take on the interstellar objects identified to date. Earthbound scopes and orbital monitors tend to pick up items coming from favored angles, with defined luminosity traits and set path shapes. The trio of verified interstellar guests might not mirror the full array, much like early exoplanet finds, mainly scorching gas giants hugging their host stars, failed to capture the spectrum of worlds. The inbound path of 3I Atlas from southern constellations caught some stargazers off guard, as they anticipated these visitors would mainly stream in along the Milky Way's spin. This offbeat route hints that our ideas on distributing interstellar objects are still evolving, or that close stellar flybys can jumble an item's initial path in ways that hide its roots. Advancing tools in astronomy will vastly enhance our capacity to tackle these issues. The Rubin Observatory's decade-long scan of the cosmos and timeline will uncover hundreds of interstellar objects, yielding datasets robust enough to validate ideas on their beginnings, makeups, and courses. Orbital infrared observatories will probe their heat signatures and molecular profiles with remarkable detail. These growing troves of information will either affirm that interstellar objects match the patterns foreseen by planet-building science, or highlight oddities calling for bolder theories. Should extraterrestrial craft lurk within the roving throng, larger datasets and improved detection tools will eventually reveal the contrived aspects of such objects via minor yet consistent anomalies in their trajectories and compositions. We shouldn't downplay the deeper philosophical ramifications of this ongoing quietude. Every interstellar visitor we examine adds yet another piece to the puzzle, bolstering the idea that advanced civilizations capable of cosmic construction either never arose, evade our present tools entirely, or opt to stay hidden behind unassuming markers. With each verified ordinary interloper, the case for interstellar isolation strengthens. Still, lacking proof doesn't prove non-existence, especially given our constrained observational reach and modest collection of examples. The cosmos might still harbor shocks that upend our views on sentience, innovation, and their traces amid the stars. Whether 3 Atlas turns out to be a natural wanderer or something engineered, it contributes another fragment to our species' persistent quest to grasp its role amid the universe's vast assembly. As we delve deeper into ever wilder conjectures, it's crucial to highlight the gap between empirical findings and flights of fancy. The authentic universe, unveiled through methodical scrutiny and rigorous examination, has already shown itself to be profoundly bizarre and captivating without needing fantastical embellishments. If that enigma encompasses alien minds is still unresolved, though coming revelations will settle it with the unmistakable truth that data alone delivers. Part 10. The ultimate movie-style nightmare. Stealthy infiltration through tiny propagators. Now we dive headfirst into wildly imaginative territory, where the line separating credible sci-fi from tangible facts dissolves into plots that could shatter our assumptions about existence, cognition, and the broader universe. This exploration pushes to the fringes of what's conceivable. Concepts so outlandish they demand ignoring several established laws of nature, yet tethered just enough to real science to spark our creativity. Envision this setup. 3 Atlas goes beyond a simple scout or standard vessel. It's actually a carrier for something far sneakier and more advanced. Buried deep in its frozen core, tiny gadgets, or maybe even custom-built organisms, what we'll term microseeds, rest inactive, primed to stir upon hitting precise ecological cues. These might be nanoscale machines built to endure the brutal rigors of interstar voids over eons. Alternatively, they could embody a galaxy-spanning biology that propagates across stellar realms precisely this way. This notion draws some roots from legitimate theoretical discourse. The panspermia theory, though debated and unconfirmed, posits that life could disseminate across the Milky Way on comets, rocks, and similar cosmic drifters. Certain scientists argue that resilient microbes might weather space's deadly rays, emptiness, and frigid depths for ages, potentially millions or billions of years, then ignite fresh biospheres upon landing in habitable zones. Yet, our imagined tale escalates well past mere drifting dissemination. These posited microseeds would embody deliberate inventions, not just hardy survivors of cosmic journeys, but one's programmed to lie low until exact wake-up signals arise. They could ignite in response to tech-heavy electromagnetic signals, springing to life only near broadcasts, chemical emissions, or other hallmarks of sapient activity. Or they might activate via stellar light profiles, rousing as their carrier nears suns with distinct color spectra. The technical hurdles would dwarf anything we can fathom today. Such minuscule units would have to preserve their form over immense epochs, battered by stellar blasts, spec collisions, and wild thermal swings in the interstellar chill. They'd demand energy reserves outlasting many suns' lifespans, data repositories immune to erosion across eras rivaling planetary histories, and self-replicating faculties to forge intricate setups from extraterrestrial resources. But should this tech prove feasible, the tactical consequences would chill to the bone. One rogue like 3 Atlas might transport countless billions or trillions of these infinitesimal invaders, each poised to plant roots on whatever planet it claims. The takeover, should we label it so, would creep in wordlessly, enduringly, and imperceptibly until the startup sequence kicked off. In this hypothetical chronicle, the rousing might play out hundreds or thousands of years post 3 Atlas's solar system flyby. Conceivably, these microseeds await Earth's progress, hitting key benchmarks. When humanity finally masters travel between the stars, when our numbers swell to critical thresholds, or when our factories emit specific traces in the atmosphere, This postponement would fulfill several tactical aims, providing an opportunity for in-depth scouting of our society, guaranteeing that the triggering happens only once we've advanced enough to meet the objectives those seeds are meant to achieve, and preserving a veil of ambiguity linking the initial dispatch to the later activation. Yet, this is where stark facts disrupt the imaginative construct. The brutal environment endured by 3 Atlas over its cosmic voyage would pose nearly impossible obstacles to any intricate tech or life forms. Just the galactic rays would erode molecular bonds progressively across millions of years, not to mention the eons-spanning trek implied by its estimated antiquity. Even Earth's toughest survivors against radiation couldn't withstand such extended bombardment. The eruptive frenzy that renders 3 Atlas observable as a comet would add further perils for any tiny passengers. As fleeting ices vaporize and billow out into the void, they'd sweep up grit and minuscule inclusions lodged in the core. The ferocity of this cycle, repeating each stellar close encounter across its ancient path, would probably obliterate fragile assemblies and disperse any nanoscale elements over immense expanses. The sheer thinning effects also undermine the viability of this transport method. Suppose 3 Atlas harbored trillions of tiny seeds. Still, most would get flung into the emptiness amid those venting episodes, vanishing into the interstellar gulf. The scant survivors that could drift toward our system would encounter further dispersal in Earth's air and ecosystems, rendering any significant buildup in one spot all but unattainable. The minimal distance of 88 astronomical units offers yet another sobering assessment of this hypothetical plot. 3 Atlas will swing by our planet at about double Mars's separation, with zero chance of physical transfer. Such seeds would have to endure not just the millennial star-hopping and the savage venting, but also the trek spanning countless millions of kilometers through the solar void to arrive here. Guidelines for planetary safeguarding, crafted by agencies like NASA and ESA to shield Earth and extraterrestrial sites from pollutants, outline potential reactions to imagined debris retrieval from visitors like 3 Atlas. These steps include rigorous isolation measures, scrutiny in high-security biofacilities, and meticulous probing for life or tech indicators. However, those guidelines presuppose targeted retrieval operations, not the incidental netting of infinitesimal debris hurled over colossal gaps. Spotting such a fanciful peril would demand Herculean efforts in surveillance. How would one hunt for dormant micromachines or life that could lurk inactive for ages? What markers might they emit to stand out from everyday microbes, cosmic specks, or local pollutants? It'd resemble hunting pins in a stack vast as our whole star system. Extended array radar setups, those employed for monitoring orbital junk and risky rocks, couldn't pick up items as diminutive as these seeds. Visual scans struggle even more with bits sized in microns, not kilometers. And if such watchfulness were feasible in theory, the demands on resources would be colossal, requiring non-stop oversight over Earth's surrounding spatial expanse. This highlights the core flaw in our imagined covert incursion tale. It defies basic tenets of design practicality. A society advanced enough to engineer eons-long cosmic payloads would likely command simpler, surer ways to pursue any invasion's aims. The intricacies, risks, and lags in scattering these minuscule agents render it a wildly impractical tactic, versus options such as beamed power signals, standard probes, or basic signal broadcasts. Still, the notion does offer one key insight amid our conjectural musings. It shows how our creative leaps can outpace what's physically feasible amid stellar enigmas. That blend of awe and interstellar unease, fueling true research, can also spawn apprehensions that stretch beyond credible limits. Telling apart sensible vigilance from baseless conjecture, it grows essential to handle truly novel events with care. In our documentary exploration of these situations, we must include bold, upfront warnings about their hypothetical essence. Audiences should grasp that we're venturing into realms of conjecture, not charting proven truths. Such mental exercises prove useful for broadening our perspectives on potential outcomes, yet they must not be confused with likely or even feasible occurrences. The alternative viewpoint stays simple and persuasive. The most straightforward account of 3 Atlas's actions is that comet particles act just as typical comet particles would. The entity shows every trait anticipated from ordinary cometary substance, including suitable spectral indicators, expected heat responses, and venting behaviors that align exactly with sun exposure. Extra theories aren't needed to account for what we've seen. As we approach the close of our imaginative tour through ever more intense possibilities, it's valuable to consider what these mental probes uncover regarding human behavior and our bond with interstellar unknowns. Our habit of devising outlandish accounts for odd events highlights both our ingenuity and our unease over our role in a cosmos that frequently appears unconcerned with our presence. The actual 3 Atlas, the one we've detected, quantified, and examined, hurtling across our solar system at astonishing velocity, stands as plenty impressive on its own, needing no fanciful embellishments to its tail. It's a time-worn traveler from a distant star system, bearing traces of foreign chemical makeups, granting us a short glimpse into the profound past and immense breadth of our galaxy. That's awe-inspiring enough to spark curiosity and rigorous study without resorting to ideas of incursions or concealed tech. Still, the act of delving into such concepts fulfills a role in our continued effort to comprehend our place in the stars. By stretching conjecture to extremes, we gain deeper respect for the authentic enigmas around us and the boundaries that science and data impose on sound interpretations. The cosmos has revealed itself bizarre enough via ordinary mechanisms, maybe more bizarre than our minds can easily grasp, but bizarre in manners that eventually succumb to steady watching and meticulous scrutiny. Part 11. Should 3 Atlas prove an outsider, what would our reaction be? So far, the handling has showcased the finest qualities of global scientific teamwork. A synchronized ballet of scopes, organizations, and solo scientists uniting to pull the most insight from a passing chance. Mere hours after the first spotting by the Atlas survey on July 1, 2025, a worldwide array of facilities leaped into unified efforts, showing how today's stargazing functions as a borderless collaboration. The prompt reaction adhered to long-established guidelines from years of spotting rocks and icy bodies. The Minor Planet Center at Harvard-Smithsonian Astrophysical Observatory acted as the main hub for positional data, gathering location readings from sites around the globe and honing the item's path details with every fresh input. The European Space's Space Situational Awareness Program contributed its monitoring tools, as NASA's Planetary Defense Coordination Office assessed risks of Earth hits a review that soon dismissed any crash danger, though 3 Atlas's origin from beyond our system ramped up the efforts past standard rock monitoring. The Hubble Space Telescope got top priority slots for impromptu targeting, pausing scheduled work to capture images of this one-of-a-kind guest. The James Webb Space Telescope did the same, allocating vital slots for spectral breakdowns of the object's distinctive CO2-heavy halo. Earthbound facilities, from Chile's Atacama Desert to Hawaii's Mauna Kea, added supporting data-spanning light wavelengths. This unified effort highlights the progress in the stargazing field for quick-action cases. In contrast to astronomy's beginnings, where finds might linger in personal logs for months or years, current detection projects instantly distribute info via reliable channels. The International Astronomical Union's Central Bureau for Astronomical Telegrams, for all its old-fashioned title, delivers almost instant alerts on major finds to experts everywhere. The data sharing around 3 Atlas has been impressively open. NASA's main site offers steady reports on findings packed with in-depth specs and user-friendly summaries for everyday readers. The European Space Agency has issued comparable reports, stressing the teamwork involved in the monitoring effort for this object. Well-known astronomy outlets such as Sky and Telescope magazine have offered in-depth technical analyses paired with hands-on tips for hobbyist stargazers eager to spot this extrasolar newcomer using their personal scopes. Now, consider if those hypothetical ideas we explored earlier in our examination turned out to be spot on. What if upcoming data started showing signs that defied ordinary natural explanations, like organized radio signals, deliberate path corrections, or the release of additional probes across our solar system? In what ways would our organizations and protocols expand to manage what could turn out to be the biggest breakthrough in humankind's past? The current setup offers certain directions. The International Astronomical Union maintains rules for validating remarkable assertions, demanding separate validations from various sites, before endorsing findings that upend long-held scientific views. The SETI Institute has crafted outreach plans for possible initial encounters, covering protocols for data exchange, announcements to the public, and global teamwork. Space organizations follow safeguards for planetary defense to avoid polluting Earth with extraterrestrial microbes or even stranger life varieties in theory. However, all these current structures weren't built to deal with the detection of functioning extraterrestrial tech maneuvering inside our solar system. The level of collaboration needed would surpass any prior effort in scientific endeavors. Issues of oversight would surface right away. Which global entity holds sway over encounter guidelines? How do you align reactions from countries that might see the find as a chance or a danger? What occurs when the drive for knowledge clashes with defense priorities? The governmental aspects would overwhelm. Any proof of extraterrestrial tech would right away turn into a national defense issue for all key nations on the planet. Armed forces that now regard space mostly for watching and messaging would abruptly face the prospect of intelligent beings beyond humans with possibly advanced tech superiority. The equilibrium between openness and secrecy, which has typically leaned toward disclosure in space studies, could swing sharply to secrecy and limited entry. The engineering hurdles in addressing a verified extraterrestrial arrival would strain every element of our orbital resources. Today's probes require years to get to the outer regions where tiniest Atlas sits now, and decades to hit speeds for deep space. If the thing was truly man-made and prompt messaging was wanted, our sole viable choice could be sending radio waves. If the extraterrestrial tech employed signaling methods we might identify or crack, the lack of any effective way to pick them up underscores our present shortcomings in orbital tech. Even after years of notable successes in automated probes, we're still stuck in our close solar vicinity with travel durations counted in years, not months. Any real engagement with swift extrasolar visitors would demand abilities we lack today and couldn't build fast enough to count for items like 3 Atlas. Outreach to the public would encounter without precedent obstacles. How does one reveal the find of extraterrestrial smarts without sparking widespread alarm or societal chaos? The deliberate, restrained approach that space groups have taken in 3I Atlas updates, focusing on scholarly appeal while downplaying hype, would have to adapt swiftly to cope with much wilder assertions while upholding reliability and societal confidence. Insights from past non-events would prove vital. The wow signal picked up by SETI experts in 1977 sparked huge early buzz, but in the end was a single occurrence that no one else could verify or recreate. Lately, the odd traits of Oumuamua sparked short-lived talk of non-natural routes before standard accounts took hold. Such episodes have shown experts and outreach pros the value of separating fascinating data from firm verdicts. Handling press would turn essential in any plan for verified extraterrestrial tech. The non-stop news world's hunger for big stories could swiftly bury precise scientific review under guesses and false info. Online networks would grapple with massive issues in sorting real info from trusted outlets amid the sure surge of wild theories, fakes, and twisted takes that would follow such a pivotal instant. The discovery of this interstellar object carries profound economic ramifications that alone warrant meticulous contingency planning. Stock markets could face wild fluctuations as traders grapple with incorporating the reality of verified extraterrestrial tech into their valuations. Sectors across the board might confront their very survival if extraterrestrial advancements present groundbreaking substitutes for existing power sources, mobility systems, or production methods. Sustaining worldwide financial equilibrium could hinge on how adeptly organizations navigate the shift from conjecture to irrefutable truth. Academic bodies would encounter urgent demands to overhaul syllabi, investigative focuses, and core beliefs regarding humankind's role among the stars. The repercussions for thought would permeate fields ranging from astrophysics and quantum mechanics to cultural studies, religious studies, and governance theory. Long-established centers of learning, honed over generations on earthbound occurrences, would abruptly have to weave in accounts of alien intellect to reshape their grasp of existence. The tight deadlines set by the rapid path of 3I Atlas intensify the need for prompt action in any imagined reaction plan. In contrast to the leisurely progression of typical celestial events, visitors from beyond our system show up and leave according to the dictates of natural laws, not our preferences. Crafting and executing a substantive reply would demand execution in mere months, not years, squeezing standard deliberation timelines into periods that test organizational limits. Nevertheless, the handling of 3I Atlas has showcased impressive speed despite these pressures. Astronomers around the world spotted the entity, verified its origins from another star system, organized observations across various spectra, and launched in-depth studies, all in a matter of weeks after the first sighting. This history indicates that current setups and protocols, for all their flaws, offer a sturdy base for tackling even the most novel findings. Over years, experts in SETI, life in space, and global law have refined models for dealing with verified extraterrestrial encounters. Though such groundwork can't cover every twist of real interaction, it supplies essential baselines for the swift choices required in exceptional situations. Crucially, the approach to 3I Atlas has prioritized wonder above alarm, empirical inquiry above guesswork, and joint efforts above rivalrous withholding. These principles, seen in the open exchange of data and the teamwork in analysis, outline our species' optimal strategy for unraveling universal enigmas, no matter their final resolution. This practical handling shows we hold the tools and structures needed to probe extraordinary events with competence. If those assets would suffice for genuine initial contact is still uncertain, yet the unified expert reaction to 3I Atlas offers grounds for hope in our collective capacity to manage greater stellar surprises. Shifting from musings on extraterrestrial meetings to firmer talks on broader cosmic views and research practices, the 3I Atlas affair stands as an exemplar of how today's society tackles the unfamiliar. The blend of tech prowess, systemic teamwork, and inquisitive mindset defining the 3I Atlas probe forms a blueprint for confronting enigmas that could reshape our sense of position in the cosmos. Part 12. Containment or curiosity. Weighing the drive for knowledge against potential hazards captures a core conflict in our pursuit of discovery. It's the very push that propelled us to sail seas, scale peaks, and probe the void, even amid perils. For 3I Atlas, this equilibrium has swung firmly to exploration, and rightly so. Its course and traits rule out nearly all practical isolation options while opening vast avenues for insight. Long-standing guidelines on safeguarding planets, forged from spacefaring history, offer ways to evaluate threats of cross-contamination both ways, shielding our planet from foreign microbes and shielding distant realms from earthly organisms. Yet these rules mainly target missions bringing back materials directly or vessels in near proximity, not entities streaking past our system at harmless ranges without clear biological markers. At its heart, planetary safeguarding relies on gauging dangers and scaling reactions accordingly. When NASA's Perseverance rover gathered specimens from M for Mars, meticulous safeguards were devised for the astronauts' eventual homecoming to guarantee that no potential Martian microbes could infiltrate Earth's ecosystem. In a comparable vein, probes headed to promising worlds like Europa must endure rigorous decontamination protocols to avoid introducing earthly contaminants to extraterrestrial habitats. The situation with 3I Atlas is entirely distinct, with its closest pass at 1.8 astronomical units, about 270 million kilometers. There's zero chance of any physical transfer of matter to our planet. Intercepting it via spacecraft isn't on the agenda and isn't viable anyway, considering today's tech limits and its blistering speed. Debates over containment turn mostly theoretical when the item under scrutiny stays far too distant to pose any risk. Such a secure separation has fostered an exceptionally forthright strategy for distributing data and fostering joint research efforts. Photos from the Hubble Space Telescope, spectral readings from the James Webb, and terrestrial telescope findings are all accessible via routine astronomy databases, enabling global experts to scrutinize identical datasets and cross-check one another's findings. This candor embodies the pinnacle of scientific inquiry. Diverse teams poring over the same proof and arriving at aligned judgments on the entity's natural makeup. The tradition of freely accessible repositories built up. Credible outlets have steadfastly highlighted the item's odd traits alongside its earthly roots, owning gaps in knowledge without veering into wild claims. Shadier outlets, meanwhile, have at times inflated early data, blurred guesses with certainties, or pushed tales of official hush-ups on interstellar visitors. Imagery conveyance is key in these infocurrents. Enhanced shots from Hubble and Webb of 3IE Atlas, tweaked to highlight key traits, can strike lay viewers as eerie and supernatural. The trick is framing them to stress factual value over thrill, illustrating how the spotted elements align with comet patterns instead of implying advanced otherworldly craft. The dilemma of restraint versus exploration shifts when shifting from material lockdown to data lockdown. Ought some stellar revelations face secrecy or limited release? Experts mostly say no, contending that the gains from collective openness surpass imagined threats from exposed space info. This stance draws from both hands-on and ethical angles. On the practical side, stargazing thrives as an international pursuit, with scholars exchanging info, validating work, and advancing shared insights. Philosophically speaking, observations from orbit have traditionally fostered unity among people instead of discord, highlighting our shared origins in the cosmos over earthly disputes. Past instances of potentially odd celestial findings have reinforced the value of ongoing transparency. In the 1960s, the identification of pulsars was momentarily labeled LGM, standing for Little Green Men, before unveiling groundbreaking physical principles instead of extraterrestrial minds. Similarly, the WOW signal picked up by SETI experts stays unresolved, yet has undergone extensive public scrutiny and examination. Oumuamua's distinctive traits, too, were explored via open global partnerships rather than secretive initiatives. Contributions from citizen scientists to the 3I Atlas sightings underscore a preference for inquiry over secrecy. Hobbyists using basic gear have recorded photos and brightness variations that enhance expert data, enriching the repository of knowledge that shapes our evolving scientific insights. Such broadening of astronomical inquiry couldn't thrive in restrictive environments, yet it has clearly boosted authentic progress in the field. The FAREX probe's prospective function in charting 3 Atlas's sprawling carbon dioxide envelope shows how upcoming surveys will broaden our capacity to examine these wanderers. Broad-spectrum infrared efforts, such as SphereX, pair with the in-depth spectral analysis from Webb to build full profiles of cosmic travelers that individual tools couldn't achieve solo. Ahead, the Vera Rubin Observatory's long-term survey of space and time is set to transform our grasp of interstellar bodies by spotting hundreds during its intended run. This data-driven method could either validate that items like 3 Atlas follow typical natural patterns with foreseeable spreads, or uncover oddities calling for bolder interpretations. The way institutions tackle these upcoming finds has been molded by the 3 Atlas episode. Swift alignment among telescopes, clear-cut protocols for exchanging data, and a focus on cross-border teamwork offer a blueprint for managing even stranger events. If truly bizarre entities are ever spotted, the research community seems ready to probe them using the identical open joint strategies that define the 3 Atlas probe. The mix of doubt and receptivity seen in astronomers' handling of 3 Atlas furnishes yet another guide for what lies ahead. Sound scientific doubt insists on robust proof for bold assertions, yet it also calls for staying amenable to ideas beyond present knowledge. The 3 Atlas probe has illustrated how to uphold this equilibrium, recognizing peculiar features without veering into baseless guesses. Evaluations of risks for coming interstellar guests will draw from the 3 Atlas model. The body's harmless trip across our solar system, its steady adherence to standard comet dynamics, and the lack of any odd indicators set standard benchmarks for akin finds. Subsequent visitors straying far from this norm may call for altered strategies, but the starting point will probably stick to probing natural causes thoroughly prior to eyeing wilder options. Beyond its core outcomes, the 3 Atlas probe's teaching worth highlights how contemporary astronomy functions as a joint, forthright, proof-driven pursuit. It reveals how organizations orchestrate reactions to novel events, how open data flows speed up breakthroughs, and how expert caution prevents hasty judgments or knee-jerk rejections of the peculiar. As we shift to larger cosmic views and our species' role in the universe, the 3 Atlas probe acts as a prime example of humanity's engagement with the unfamiliar. Prioritizing wonder above alarm, teamwork over rivalry, and proof above conjecture gives grounds for hope in confronting deeper cosmic revelations on the horizon in coming years and beyond. Part 13. Vastness of the universe and our transmissions. The path that delivered 3I Atlas to our stellar threshold covers spans and durations that stretch beyond human grasp. Still, comprehending these magnitudes is essential for appreciating the entity's importance and our position amid the grand drama of cosmic development. Discussing origins in the thick disk of the galaxy conjures a narrative that kicked off when the cosmos was under half its present span, when star groups varied dramatically, far removed from the stellar patterns we see in the modern era. This epoch marked the Milky Way's infancy as a turbulent breeding ground for stars. The thick disk embodies an earlier cohort of stars, born amid the galaxy's initial upheaval, about 10 to 12 billion years in the past. In contrast to the thin disk, home to our Sun in a fairly stable zone where stars trace nearly circular paths around the galactic core, the thick disk harbors stars on more irregular inclined trajectories that echo the harsh circumstances of their formation. Should 3I Atlas truly hail from this primordial group, its core preserves traces of star clusters that predated our solar system's first spark within a nebula. Imagining the vastness of this odyssey takes on a lyrical quality. 3I Atlas may have roamed the galaxy for billions of years, a span during which whole waves of stars have emerged, thrived, and faded away. Enormous stars present at the start of its interstellar trek have long detonated as supernovae, dispersing heavy metals into the void and sparking fresh cycles of stellar birth. Countless planetary setups have arisen, matured, and possibly nurtured life in the interim. As this timeless drifter navigated the interstellar void, the durations involved eclipse any earthly notion of time. Assuming 3I Atlas has drifted for around 5 billion years, a modest projection tied to its thick disk roots, it has journeyed over 1,000 times beyond the span of advanced life on our world. In that interval, Earth has witnessed the Cambrian burst of diversity, 5 devastating extinction events, the dominance and demise of dinosaurs, and the dawn of human societies. From the viewpoint of this celestial nomad, though, all of humankind's saga amounts to just the last fleeting instant of its epic, multi-billion-year trek. The spans it has covered are no less astonishing. Despite 3I Atlas's blistering pace exceeding 130 mph, navigating major swaths of the galaxy demands millions of years. Throughout its ramblings, it might have brushed past hundreds or thousands of star systems, drawing near enough to some for their gravity to nudge it, maybe even observing the genesis of worlds orbiting suns that have since aged into bloated red giants approaching oblivion. Such brushes occurred quietly and unseen, deep in the cosmic expanse, beyond any observer's reach to document them. Every gravitational nudge would have subtly shifted its path, either boosting or draining its momentum in a vast interstellar version of cosmic billiards, spanning light years. The buildup from millions of these interactions might explain 3I Atlas's present blistering speed, with each stellar close call delivering a minor jolt that gradually propelled this veteran traveler to its ferocious velocity. Against this galactic canvas, the object's chemical makeup gains profound meaning. Its abundance of carbon dioxide could mirror the conditions near a star vastly unlike our own, in a stellar setting dominated by alternate fusion reactions, unique planetary formations, or distinct interstellar gases. 3. Atlas acts as a specimen of extraterrestrial makeup, bearing molecular clues from star fields we might never explore firsthand. This molecular detective work deepens our grasp of the galaxy's development beyond what traditional stargazing achieves. Though we probe remote suns via their emitted light and deduce traits through spectral analysis, interstellar visitors like 3I-8LAS deliver tangible chunks of matter forged around those far-off stars eons ago. It's akin to receiving fragments from otherworldly realms right at our threshold, packed with isotopic balances, rock structures, and gas contents that unveil their origins. Our expanding radiosphere, the growing dome of signals broadcasting our existence across space, offers a sobering lens on these immense scales. From Marconi's pioneering radio broadcasts in the late 1800s, our transmissions have propagated at light speed, now extending to stars about 120 light-years from home. This feels vast until we consider the Milky Way's 100,000 light-year width, rendering our signal footprint a mere droplet in the galactic sea. That sphere encompasses maybe a few thousand star systems amid the galaxy's 400 billion suns. Even our strongest signals, crafted for chats across our solar system's voids, would register as barely audible murmurs to detectors orbiting close stars. The notion that 3I-Atlas could have been drawn toward our solar system, detecting us through our electromagnetic footprint, seems unlikely once we account for the object's estimated age and the tiny portion of the galaxy that our radio broadcasts actually reach. The quiet we hear while scanning for transmissions from alien societies, the profound hush at the heart of the Fermi paradox, feels far less puzzling when set against these immense expanses. Should the galaxy host thousands of civilizations sending out radio waves, the sheer distances would render their emissions incredibly weak and hard to pick up. The inverse square law dictating electromagnetic propagation ensures that increasing the distance to a signal source by twofold slashes its perceived intensity by 4 times, turning interstellar messaging into a daunting engineering hurdle, even for tech vastly superior to what we possess today. The power demands of such cosmic dialogues eclipse anything in human engineering. To send a detectable beam over average interstellar gaps, you'd need output levels rivaling those of modest stars. Narrow, laser-like beams aimed at particular star systems would still call for energy production on a scale we can't yet dream of. Such fundamental barriers might account for why SETI efforts have turned up no solid signs of artificial broadcasts after years of monitoring countless frequencies and sky patches. Similar power hurdles plague interstellar voyages, offering a lens to assess the feasibility of the possibilities we've delved into during this study. Propelling even a modest probe to speeds suited for swift jaunts between stars would demand energy matching the yearly electrical yield of big industrial powers. Bigger ships would scale up those needs, possibly surpassing all the power humanity generates at present. Thirdly, Oumuamua's attainment of blistering speeds via gravitational slingshots shows how the galaxy can act as a natural booster for items willing to gather momentum over repeated flybys of stars. This built-in process offers a reasonable account for the object's blistering pace, bypassing the need for bizarre engines or man-made boosts. The odds tied to spotting interstellar wanderers sharpen when measured against the galaxy's grand dimensions. If the birth of planetary setups commonly flings out heaps of rocky and frozen scraps per simulation models, then the Milky Way ought to teem with trillions of rogues akin to Oumuamua. The few detections per year that the Rubin Observatory aims to snag merely scratch the surface of this enormous horde, hemmed in by spotting limits, tech boundaries, and survey scopes. From this numbers angle, the variety and makeup in physics seen in our handful of verified interstellar drifters likely hints at just a sliver of the full spectrum of traits and builds among the galaxy's nomadic crowd. Upcoming scans could uncover wanderers with traits even stranger than Oumuamua's, broadening our grasp of the dynamics and setups around far-off suns. The timelines of the galaxy's growth offer yet another angle on Oumuamua's import. Over eons, the Milky Way's makeup has grown richer in heavy elements as wave after wave of stars forge them from lighter stuff and scatter them via stellar blasts. Early-born items like Oumuamua, assuming our timeline guesses hold, would mirror the elemental setup of a fresher, metal-poor cosmos, starkly unlike the starscape we see now. This time-based layer deepens the puzzle of decoding the elemental clues in these old cosmic travelers. The heavy carbon dioxide presence setting Oumuamua, apart from modern comets, could well have been standard for bodies born near first-wave stars, whose blends and heat traits diverged from our sun's. Probing those primordial birth settings might unlock secrets of the galaxy's initial chemical shifts that no other method could reveal. Nearing the wrap-up of our probe into Oumuamua and its broader meanings, these stellar vastnesses highlight both the marvel of this find and the bounds of our viewpoint. We're probing a relic that has spanned the galaxy's long march through deep time, bearing traces from star realms alien to our own, and forging a tangible tie to events unfolding billions of years prior to the formation of Earth. Nevertheless, despite its immense importance in the grand scheme of the cosmos, 3I Atlas stays entirely understandable through the lens of contemporary science. Its movements adhere to physical principles, its chemical makeup mirrors ordinary reactions, and its path conforms to the gravitational rules that direct all celestial bodies across the universe. The blend of its strange beginnings and predictable actions highlights the variety alongside the core consistency of natural mechanisms at work throughout the Milky Way. This viewpoint, encompassing vast cosmic dimensions and universal laws, forms the basis for our concluding thoughts on the meaning of 3 Atlas in terms of human insight and our enduring bond with the universe from which we emerged. Part 14. Hope amid quiet data streams. The deepest boon that 3I Atlas bestows upon us may not stem from wild theories about its source or intent, but rather from its peaceful transit through our stellar vicinity. In times when earthly crises feel insurmountable and prospects unclear, a certain comfort arises from an interstellar traveler that shows up right on schedule, acts in full accordance with physical dictates, and slips away into the void without altering even one earthly twilight. Such comfort holds real weight. It signifies the success of rational inquiry against fears of the unknown, the dominance of meticulous scrutiny over baseless guesses. Upon initial spotting of 3 Atlas hurtling toward our system at remarkable speed, apprehension toward the unfamiliar could have gripped us. Yet, mere weeks after its identification, worldwide groups of skywatchers had mapped its precise route, examined its molecular structure, and assuredly forecasted its benign flyby. This showcases peak human intellect and teamwork. The bounty of findings from 3 Atlas has already surpassed the long-term yields of many stellar finds. Its atypical abundance of carbon dioxide has questioned our views on standard comet makeup, compelling scientists to craft fresh theories on how volatile balances differ in items born under varied star systems. Far from just scholarly trivia, this deepens our grasp of world-building dynamics active galaxy-wide. Data from the James Webb Space Telescope's spectra offers concrete proof of the molecular transformations happening near distant suns. The elevated CO2 to H2O proportion in 3 atlases, coma points to origins close to carbon dioxide frost boundaries in young planetary disks, or perhaps long-term surface alteration by radiation across eons. Both explanations broaden our view of the range of settings and forces molding frozen entities outside our own system. These molecular revelations reach well past comet studies alone. Grasping variations in volatile stocks across interstellar origins aids stargazers in honing simulations of planet development and change, crucial for hunting livable planets orbiting other suns. Should CO2-heavy settings prove widespread in key phases of cosmic history, it could reshape predictions on locations and timings for life-friendly conditions as we define them. The organized reaction to 3 Atlas underscores the impressive speed of today's astronomical teamwork facing novel events. The Atlas survey first spotted the body, The Minor Planet Center orchestrated worldwide monitoring. Hubble and Webb telescopes delivered in-depth imaging, while Earthbound facilities added supporting info-wall achieved in a timeline unthinkable generations back. This teamwork goes further than tech prowess, embodying a dedication to collective wisdom and joint exploration. Choosing to release sighting records via routine astro databases underscores the research world's belief that space wonders are humanity's shared inheritance, not the property of specific groups or countries. This candor gains extra import when probing items that could mark our initial brushes with extrasolar oddities. The forthrightness defining the 3i Atlas probe sets a model for managing wilder finds ahead. If skywatchers someday uncover truly bizarre entities defying known natural rules, the established norm of free data exchange and group scrutiny stands as the optimal path to sort fact from glitch, device flaw, or true stellar enigma. The outreach to the public. The case of 3i Atlas highlights the potential rewards and obstacles involved in explaining intricate scientific ideas to everyday viewers amid today's media landscape. Reputable research organizations have mostly managed to share details on the item's distinctive traits and its earthly beginnings, recognizing ambiguities without indulging in baseless guesses. Such reporting has informed countless individuals on interstellar visitors, the layout of our galaxy, comet dynamics, and the techniques experts employ to examine distant events. However, those very platforms that facilitate strong public learning about science also spread false information and wild theories that skew perceptions of space-based findings. Ensuring sensible discussions on celestial events grows more intricate as online networks favor user interaction above truthfulness, often boosting sensational assertions while sidelining balanced expert reviews. The 3i Atlas example shows how research bodies can tackle these outreach hurdles via steady communication, sharp separations between proven data and hypothetical views, and steady efforts to clarify errors. This method offers a blueprint for managing upcoming revelations that could be tougher to present clearly. Real-time monitoring sites, media briefings, and learning resources have turned 3i Atlas into one of the most open-to-the-public astronomical events in recent times. Hobbyists in astronomy have added their sightings, school assignments have examined open datasets, and public involvement programs have drawn in thousands to track the item's luminosity and actions. This broadening of access to astronomical studies marks one of the brightest developments in contemporary research. The guesses encircling 3i Atlas, including the possibilities examined in this probe, fulfill valid roles past simple amusement. Pondering outlandish options pushes scientists to deliberate more deeply on what sets organic from man-made objects in the cosmos, spurs creation of detection methods to disprove standard explanations, and underscores that the cosmos might yet reveal shocks that upend existing views. Yet the real worth of such guesses stems from their ties to proof, not their flair. The possibilities we've delved into gain importance when they yield verifiable forecasts or point out weaknesses in our present insights. They turn damaging if viewed as solid truths or leveraged to stir baseless fears of space dangers. The precise line we've drawn between conjecture and research in this probe mirrors wider tenets on how insight evolves and how communities ought to handle unknowns. Research advances via the balance of bold ideas and strict validation between inventive theorizing and methodical proof assessment. 3i Atlas offers a prime illustration of how this mechanism functions amid truly novel occurrences. The journey of comprehension that defined the 3i Atlas inquiry, from first spotting through in-depth scrutiny to assured judgments on its organic roots, shows the gradual buildup of scientific insight. Initial sightings sparked doubts over the item's odd features. Follow-up assessments sharpened our grasp of its makeup and patterns. In time, sufficient proof gathered to back firm determinations about its essence as an old, elementally unique, yet essentially organic comet. This shift from doubt to clarity embodies research at its peak, revealing how steady watching and precise review can unravel seemingly enigmatic occurrences. The method instills hope in our capacity to decode even stranger space finds ahead as our detection tools keep advancing. Prospects for new revelations appear vast when viewing 3I Atlas's role in the growing list of interstellar items. The Vera Rubin Observatory's ongoing space-time scan will spot hundreds of like intruders in the coming 10 years, shifting such objects from oddities to everyday sights in astronomy. This surge in numbers will allow probes into their group traits, elemental variety, and motion behaviors that current limited examples can't support. Every fresh find will contribute to unraveling the enigmas of galaxy growth, world building, and matter spread across interstellar voids. The elemental markers rendering 3I Atlas distinctive could turn out to mirror widespread traits. Such phenomena might arise from unusual environmental factors near particular kinds of stars, or they could truly stand out as uncommon instances of peculiar activity that happens solely in precise conditions. The tools that facilitated the 3 Atlas study precise broad area observations, swift subsequent examinations, orbital spectral analysis, and worldwide collaboration systems are advancing at impressive speeds. Upcoming interstellar travelers will be spotted sooner, examined in greater depth, and comprehended faster than today's cases. This advancement in technology instills optimism that even truly peculiar items would be identified and investigated thoroughly. The wider framework of space exploration, embodied by 3 Atlas, reaches well past the details of this single entity. Every interstellar arrival broadens our first-hand access to galactic substances and dynamics, supplementing the indirect data obtained via starlight analysis and conceptual simulations. These entities act as envoys from the cosmos, bearing details about stellar settings we might never explore in person. The deeper philosophical aspects of examining such items merit attention equal to their research merits. 3 Atlas links us directly to the profound past of our galaxy, to events predating our solar system's formation, to chemical realms that molded elements now speeding by our planetary threshold. This link offers insight into our role within universal development and the persistence of natural laws over immense distances and durations. As we wrap up our probe into 3 Atlas and its ramifications, the dominant motif that arises is one of effective scholarly breakthrough driven by data, enriched by creativity, yet firmly rooted in meticulous scrutiny and strict evaluation. The entity has tested our preconceptions, broadened our insights, and offered a practical example of how contemporary stargazing tackles the unfamiliar. The direst possibility that sparked our inquiry, the chance of interstellar disaster or extraterrestrial incursion, has turned out to be baseless, supplanted by a subtler yet profoundly significant narrative of primordial reactions, stellar progression, and the extraordinary strengths of human intellectual pursuit. By substituting apprehension with comprehension, 3 Atlas has delivered what may be the greatest boon any spacefarer could bestow. The proof that steady monitoring and joint research can clarify even the most obscure, universal enigmas. Part 15. Farewell, Stellar Herald. As 3 Atlas pursues its timeless voyage away from our sun, dimming daily into the star-speckled void whence it emerged, we retain visuals that will persist well after the body itself slips beyond the grasp of our finest instruments. The Hubble Space Telescope's stunning images depict a hazy, star-resembling dot encircled by the delicate sheath of its carbon dioxide haze, a stellar holiday bauble hanging amid the boundless void of the cosmos. Webb's thermal imaging uncovers the chemical markers of that haze with exacting clarity. Every absorption feature serves as a term in the primordial molecular dialect this wanderer transports from its origin near a distant sun. The path diagrams narrate their distinct tale of orbital harmony. Graceful arcs sweep over charts illustrating 3I Atlas's route across our solar domain, beyond Mars's path, encircling the sun at closest approach and outward toward the outer planet's domain prior to venturing into the void between stars. These represent not the erratic routes of earthly politics or finances, but the tranquil accuracy of heavenly motion, as certain as dawn and as reliable as the cycle of seasons. There's a profound reassurance in this foreseeability, this stellar constancy that functions independent of human meddling or dominance. While our earthly realm swirls with doubt, 3 Atlas adheres to principles that have directed spatial movement since the cosmos's inception. Its exit timed not by mortal choice, but by the core forces that define existence. In an era of engineered worry and contrived haste, such universal steadiness delivers a deep sense of solace, the response to our study's key query. What's the gravest outcome has turned out to be reassuringly ordinary. No cinematic apocalypse looms, no extraterrestrial assault endangers our society, no stellar interference will shift Earth's path or weather patterns. The severest risk in physical terms amounts to absolutely zero. 3 Atlas will exit our solar system just as it entered, quietly, securely, and in line with the exact forecasts of calculative physics. Yet labeling this result ordinary overlooks its deeper import. The reality that we can foresee the actions of a body that has journeyed for perhaps billions of years, that originated near a sun we've never observed, that this remarkable object bears traces of chemical environments that remain largely uncharted in our direct explorations. Such reliability stands as a pinnacle achievement in the realm of science. The principles governing physics exhibit unwavering uniformity, ensuring that events spanning vast interstellar expanses and eons of geological history adhere to identical core principles. The peculiarities uncovered by 3I Atlas hold equal intrigue, even as they stem from entirely natural causes. Its composition, dominated by carbon dioxide, upends conventional views on comet makeup, broadening our grasp of the varied substances that coalesce near diverse stellar systems. Evidence of its thick disk origins in the galaxy hints at development in stellar settings far removed from our own cosmic vicinity, yielding a pristine specimen of primordial galactic compounds for in-depth examination. These distinctive traits are already reshaping astronomers' perspectives on planet-building processes, the development of comets, and the range of chemicals in interstellar wanderers. Studies on 3I Atlas will endure as key references for years as scholars weave its insights into overarching models of how frozen entities assemble and change across the galaxy. The broader implications reach well past this lone entity, shedding light on mechanisms at work amid myriad remote stars. The hypothetical scenarios we've delved into during this probe encompassing extraterrestrial tech, lost societies, or unconventional physics have fulfilled their role in sparking creativity and underscoring the inquiries sparked by true astronomical enigmas. Yet, the data steadfastly aligns with commonplace origins that, though extraordinary, fit snugly within established physical frameworks. This resolution need not leave us unsatisfied. The cosmos, through its innate workings, has already revealed depths of oddity and splendor, spanning realms from quantum intricacies to gravitational singularities and the hastening growth of the universe itself. Introducing sentient machines or arcane innovations into this tapestry of marvels may well be superfluous to evoking the awe and expansive viewpoint that fuels our pursuit of knowledge. An apt soundtrack for bidding adieu to 3I Atlas might eschew foreboding or victorious strains in favor of meditative ones, evoking both the enigma and the graspability of celestial events. Selections like Holst's The Planets or Barber's Adagio for Strings could suit, conjuring the immensity of the void while echoing human sentiment. The mood ought to foster introspection over thrill, awe over dread. In this inquiry, we've strived to delineate firm lines between verified knowledge and creative musing. Transitions from empirical findings to supposition have been clearly flagged, enabling audiences to separate verifiable truths from flights of fancy. This forthrightness underscores not only scholarly integrity, but also essential pragmatism amid times when falsehoods proliferate quicker than verifications can counter them. The core takeaway from our examination steers clear of collision perils or conquest tales, focusing instead on the quieter peril of stellar unease, the apprehension triggered by encounters with the unfamiliar. 3I Atlas illustrates how such apprehensions yield to methodical scrutiny, rigorous evaluation, and global teamwork among experts dedicated to fact-driven insights. Closing title cards in our film could guide curious minds to the trove of open-access materials underpinning this work. NASA's dedicated sections on 3I Atlas deliver reliable overviews of key observations. The Space Telescope Science Institute's repositories house the raw Hubble and Webb visuals and spectral data shaping our comprehension. Scholarly publications and mainstream stargazing outlets supply in-depth critiques paired with approachable breakdowns for everyday readers. These assets go beyond simple listings. They capture the inclusive ethos that defined the 3I Atlas probe from the outset. Opting to release sighting records via routine astronomical databases signals a dedication to collective wisdom that crosses borders and organizational divides. This accessibility instills optimism for managing bolder celestial revelations down the line. Prospects of incoming interstellar travelers infuse our parting from 3I Atlas with eager expectation. The Rubin Observatory stands poised to spot scores of comparable bodies in the next 10 years, each bearing unique teachings on stellar compounds, world building, and the throng of nomads traversing the spaces between stars. A few could exhibit even greater chemical quirks than 3I Atlas. While others may present traits that test our foundational assumptions, these revelations will position astronomers to view interstellar objects from fresh perspectives. Every new find will enrich the expanding repository of data on their traits, paving the way for analytical examinations that our limited existing collection simply cannot support. Insights into their demographic profiles, compositional variety, and orbital behaviors, uncovered by upcoming observational campaigns, will shape models of cosmic development and world-building processes that reach well past our immediate stellar surroundings. The acknowledgments honoring the facilities, repositories, and dedicated scientists behind the 3I Atlas project go further than simple recognition. They highlight how groundbreaking advancements in science arise from interconnected teams, bolstered by organizational backing instead of solitary brilliance or personal drive in isolation. The seamless integration of terrestrial observatories, orbital instruments, and information repositories that allowed for swift analysis of this extraterrestrial guest exemplifies the pinnacle of contemporary stargazing. As 3 Atlas recedes into the vast expanse, propelled by the velocity gathered over its eons-long voyage across the void between stars, it bequeaths more than raw observations and scholarly publications. It offers a vivid illustration of humanity's method for confronting the unfamiliar, employing tools of exploration over arms of conflict, driven by wonder instead of apprehension, and fostered through partnership rather than rivalry. Such decisions embody our noblest visions for interacting with the enigmas of the heavens, enigmas that could dwarf even this timeless nomad from the interstellar realms. The quiet that ensues after 3I Atlas's exit holds not void, but anticipation, poised for the subsequent celestial envoy that is bound to appear, bearing its unique molecular markers from remote astral domains, its distinct puzzles for our comprehension, and its fresh prospects for broadening our grasp of the cosmos that birthed us. Within that pause, in that persistent gaze toward the heavens, resides maybe the most optimistic facet of our bond with the universe. The belief that endless marvels await revelation, endless inquiries demand pursuit, and endless motivations exist to tilt our eyes starward with intrigue over dread. The soft dimming that may cap our observational tale trails 3 Atlas as it merges into the celestial tapestry. No more a separate entity, it rejoins the interstellar expanse from which it momentarily detached. Its transit across our star system marks merely a fleeting span in an odyssey spanning eras of planetary timescales, destined to persist for such durations yet to come. We were fortunate to observe this ephemeral stellar interlude, to examine this venerable voyager, and to weave its narrative into the burgeoning archive of spectacles that populate the voids among the stars. Rest well, stellar herald. Gratitude for the insights, the findings, and the nudge that the cosmos endures as infinitely odder and more enchanting than our grounded fancies could conceive. Fare well on your onward path across the Milky Way, bearing the molecular enigmas and primordial recollections still sealed in your core. evidence of astral settings and birthing circumstances that predated our planet's embrace by its parent sun. Until we encounter your kin from far-flung constellations, bygone eras, and remote reaches of the galactic wilds encircling our modest yet extraordinary world.